This is part 4 of the FACIT N4000 paper tape punch restoration. If you've watched the previous videos, then you'll know that so far I've stripped the chassis down, repaired some damage on various parts of this, and today I'm going to be looking at the tape feed mechanism. Now, I haven't had one of these before and I don't have the technical service manual, and there were several parts missing which I've had to make. But there weren't any drawings available that I could find, so I was having to go online and look at photographs of complete machines to try to figure out the size and shape, etc. of the parts that were missing. And I also had to figure out how I was going to reproduce those in such a way that the geometry of the tape feed would be correct. Now, looking at the various diagrams and the way that the tape punch is laid out, it appears that the tape unspools from the platter, goes around a pulley that should be here, round the tensioner pulley, and then round a second pulley down here, and then off and into the actual tape punch mechanism. Now, as with all paper tape punches, the feed has to do several things. Firstly, of course, it has to support the reel, but if you were to just have like a turntable like on a record player, then of course once you start this turning, it's quite heavy, it will carry on turning, then the entire tape would start to loosen and you'd end up with a tangled mess of paper. So the way that these generally work is there's a tensioner pulley, and that not only tensions the tape, but as the tape is pulled, it operates a brake. Now, the brake on this one is over in this corner, and as the tape tension increases, so the brake comes off, and as the brake comes off, the platter is free to spin, and then as the tape feeds off the spool, then the tension drops and the pulley moves back, the brake starts to come back on, the tension increases, and so the idea is that that is a kind of a dynamic mechanism, like a feedback system, and that keeps a constant tension on the tape that's been fed into the punch. But there were several things on here that I was trying to figure out. The first was what this was for. It's a magnet like you find on door catches and this sort of thing. Initially I thought it was to keep the clear perspex lid closed. The lid's missing, I'll get one made at some point, but it seemed to be in the wrong place. Also, I don't know what form the brackets are that the pulleys go onto. This one was sheared off completely. As you can see, I've drilled it out and I've countersunk it from the underside to accept an M3 screw. It was only a 2mm section going through there, so I've gone up to 3mm, which gives about double the area, so it should be a lot stronger. So looking at various diagrams and looking at the way the mechanism works, we'll have a look inside in a minute. I've had to make several parts. Now, firstly, I've had to make the pulleys. Initially I was going to make them in black Delrin, but I only had white on hand and I've made them in white, but I actually think I prefer that to the black. So there's one pulley that goes on the tensioner arm, but as you can see, it's not the right height. It's sitting below the level of the tape spool, so this will have to be raised. But looking at the images, it seems that there's not only the spindle this sits on, but a small kind of a metal shoe that goes on here, and its purpose seems to be to hold this against this magnet. So as you can see, when you move this back, the paper sense arm is pushed all the way out of the way. Not only that, but there's a small cable runs here, goes through to the punch head, and that operates a lever that lifts the capstan off the tape. So I think that the purpose of this is to hold the paper tape mechanism in a paper load position, frees up, moves everything out of the way, frees up the space, then you can drop the new paper tape spool on there and lace it up. So I had to figure out what shape that was going to be. Now, I don't know if I got these right, but they seem to work, and I'll go through the assembly in a few minutes. So the first thing is I needed a spindle, but I needed to make the spindle the correct length, but also the spacer section at the bottom had to be the right height, so that once it's fitted and the pulley put on top, the pulley sitting at the right height. But I also had to include one of these. I'll include some close-up photos of these parts so you can see what they actually look like. So this sits underneath this spindle, and then the whole thing bolts onto the arm, and then the pulley goes on top. I'll assemble it in a few minutes. So then I had this section here that holds the two fixed pulleys. And again, I don't know what it looked like, but there were two pegs on here. Now at first I thought the pulleys screw onto these, but there isn't a hole in the second one. So I think the way it's supposed to work is there's an arm bolts on here, and I've modified what I think it was very slightly just to make it easier for me to manufacture one. So I've come up with what I think is a working solution for that part, and it's a piece of steel that I've machined to shape. There's a recess at the end and a recess here that's going to locate it, stop it moving. But the other thing I noticed is that if you put a straight edge between the centre of these two posts, then it's angled in such a way that if you were to imagine putting a couple of pulleys on the centre line running down at an angle, the pulley at the back is going to be slightly further to this side than the pulley on the left hand side. And I think the idea there is that when the paper feeds off the tensioner pulley and comes onto this pulley, it doesn't rub on the paper that's going around the first pulley. You don't need to then have different size pulleys. They can be the same size, but they're slightly staggered. It's only about a millimetre, half a millimetre, but obviously the paper's only 0.2 millimetres thick, so that's all you need to keep the paper separated. And the idea with this is it will go on here. I've then made up another post with the correct height that will screw in here, so this will also hold this down. And then there's a third that will go onto here, and then the two pulleys will sit on those two posts, and everything in theory should be in the correct place. Probably can't see it on camera, but this is of course very slightly angled in line with those two bosses, so the two pulleys will be slightly staggered as they need to be. Okay, so before I go into assembling it, I'll just mention a few things about materials. As with most things, selecting the right materials will make life a lot easier further down the line. So for the spindles, I've used silver steel. It won't rust. It's very hard wearing. You can get a very good finish on it. And incidentally, the holes just so I can tighten the screws on the end. Just put a little Tommy bar through there, and then it won't spin round. So these have a very fine finish on them, and they're quite a nice sliding fit with the pulleys, and it just means the whole thing will run very freely. I did toy with the idea of putting ball races in these, but it really isn't necessary. They turn quite freely anyway. So silver steel for those. For the shoe I used mild steel, simply because it has to go onto the magnet at the back here, and tool steel is not particularly magnetic. It is magnetic because it's steel, but it's not. It doesn't have the same force when it's being pushed against the magnet as mild steel does. So that's mild steel. I used 01 tool steel for the bracket. Now I could have used brass, but these pulleys are quite exposed and probably going to get banged now and again. So I wanted this to be fairly stiff. I didn't want to have to keep making a new one or straightening it out. So 01 tool steel is quite tough. I'm using it here in its heat treated form. Normally I harden and temper tool steel, but it doesn't need to be here. You notice I polished this up, and that's not really for appearances or just for appearances. When I use tool steel, I tend to treat it to give a more resilient surface finish. if you just leave it in this polished state, it will corrode fairly quickly, and obviously I want this to stay in reasonable condition for a good length of time. So what you can do is you can effectively go through the annealing stage of a heat treatment process, and what that will do is it will allow the part to take on a colour depending on the temperature that you take it to. If you're not familiar with this process, it is quite interesting. It's kind of akin to anodizing on aluminium, except there's no separate media, there's no dye or anything. The colours are just formed by the thickness of the layer of oxide that builds upon the surface. So you start off with just the bare polished metal, and then as you heat it up you go through various temperatures. So if you take it to 176 centigrade, it will go very slightly straw coloured, then you go up through darker straw colours, brown, purple, dark blue, then it starts going lighter, then grey blue, and if you go any further than that it will turn black, which you might want. It is quite a good finish, good tough finish. But what we are aiming for today is the dark blue, which is 310 centigrade. Now although there are fixed temperatures indicated for this, there is a time element as well, so if you hold it at 310 for a long time, it will continue through the latter stages of colouring. So in other words, there's not only a temperature dependent thing here but also time. Rather than do that off camera, I thought I'd show you the method I used for heat treating these parts. It is quite interesting, and if you haven't seen it before and you want more information, then Chris over at ClickSpring has got some very good videos showing heat treating and bluing, and he's extremely good at it. He gets very good results. But I tend to use it for small parts, and not only does it make them look good, but the oxide layer gives a very good protection for the part and stops it corroding. And it is a very tough layer. Because it's part of the surface of the material, it won't flake off, and it's quite difficult to remove. So it does give a very good finish, and it's much better than just trying to paint it. So what I'll do now is set up the bench to show how I blue these, and I'll show you the bluing process. If you've seen it before, just skip through this part, but if you haven't seen it, you might find it quite interesting. Okay, I'm set up and ready to go. Got the part suspended on a piece of wire so I don't burn all the skin off my fingers while I'm trying to do this. You do need natural light when you're trying to do this. If you try and rely on an LED or incandescent bulb, it's quite hard to see the colour. The other thing is the part has to be very well polished and totally clean. So I've cleaned this with isopropyl alcohol, so I'll try to avoid touching it directly. Now if you were doing this for something that's showy, then suspending it on a piece of wire is not a good idea, because we will get some small discoloration around where the wire is. And again, if you go to Chris's channel at ClickSpring, he will show you how to make bluing trays, which essentially just metal boxes full of brass shavings that you sit the part in, and then you use a blow lamp to heat up the part. The problem heating small parts with a blow lamp is the temperature range we're looking at is very low. So if we look back at the chart, you'll see that to go from the colour we want up to completely the wrong colour is only about 20 or 30 degrees. And using a blow lamp, that temperature on a small part like this, you'll shoot straight past it before you realise. Also, trying to get the colour even across the entire part, especially long thin parts, with a blow lamp is very difficult, because one part will heat much more quickly than the others. So what you can use, and what I use mostly, is a hot air gun. All we're trying to do is heat the part. It must be in air, because it's, as I say, it's oxide that we're trying to generate, so you can't put it in something and then heat it up. You can use bluing salts, but again, even using bluing salts, it's only blues when you lift it out of the salts. The salts are just to heat the part up. So what I'm going to do is heat this up with the air gun. Be a bit noisy, so I might have to mute the track while I'm doing it. and then if you keep an eye on the part, hopefully you'll see the blue start to develop. It'll start off as a straw colour, then get darker, go through brown, then purple, and then on through blue. As soon as I get there, I'm going to drop it in the water. That's what that's there for. As I mentioned, there is a time element to this, so if you get it to the right colour, then just leave it to cool down. Then it will go past the colour you want, and it will keep changing. Okay, so I'll get this started. I'll start heating this up and see how it turns out. Incidentally, if you do get it wrong the first time, you can strip it off using wet and dry, but it's quite difficult to get off, so it's always best to try and get it right the first time. Okay, so here we go. Okay, so that's the finished part. The colour probably won't come across very well on the camera, simply because I'm under an LED light here, and it is one of those effects with colour that you need to see it in direct light, but hopefully you can see that it's taken on quite a nice dark blue colour, and it obviously retains the shine that you polished into it, so it actually looks very nice, and now it is protected against corrosion. I could possibly have gone a bit further, taking it slightly darker blue, but as I say, it's quite difficult doing it under an LED light, and I didn't want to turn it black. But it does look a lot nicer than it did, and it now won't corrode. Okay, so I'll get the machine back and we'll start to assemble these parts. Okay, so to assemble it I need to take the platter off. The brake shoe just hold it in place. You can just lift the platter straight up. I need to take this arm out so I can attach the pulley on the end of it. So we'll disconnect the spring. I'm not familiar with this, but I've been playing with it now for a few hours, so I've kind of got ways of getting it apart figured out. It's not particularly difficult, it's just a bit fiddly. So I need to pop this lever off. Hopefully you can see what I'm doing. Disconnect that lever, take the cable off. And once we've got all that out of the way, I can lift the arm straight up off the spindle. Okay, I'll take the two springs off for now. I can leave the rest of it together. And as you can see, I've drilled and countersunk the hole at the end, and that will now accept the spindle. Let's take the washer off, and the shoe, and that's held in place with a countersunk M3 screw. So obviously the screw goes through here. The shoe is offset, as is typical, and nothing's quite as simple as you first expect, so everything was a bit of a strange shape. That fits on here, and the idea with this is it sits at a particular angle, goes all the way down, and then it's held in place, stops from spinning round by the shape of the end of the arm. So once that's on, the actual spindle screws on. This is what the holes are for. So I can pop something through and I can tighten the screw. And then being countersunk, it will pull itself into the correct position as I tighten it. So make sure it's properly seated. Snug it down. Okay, and that's that piece fitted. So as you can see, the idea here is that the shoe extends the end of the arm so that this will then get captured by the magnet. The angle is controlled by the end of the arm. This being countersunk, it's not going to drag on the top of the punch deck. And then there's a washer that goes on here to increase the area that the pulley can run on, so that the pulley just slots on top. Then that's free to spin. It should be the correct height. So let's try refitting the platter. So get the machine back. So hopefully I can do this with the camera here. It's going to be a bit of a fiddle, but I think it's doable. So there's a large spring goes on the underside here. That needs to go on before the arm goes all the way down. And that locates in a couple of slots. Cable on first. And then this arm goes over this boss here. And that allows the cable to locate on the bottom part of its pulley. So we'll look at the operation of the other end of the cable in the next video when we look at the punch head. Then have another smaller spring that goes on here. And then that clips over this post. This lever operates the brake shoe. And so the way this works is this arm senses the amount of paper on the reel. There's a reed switch here and a magnet on this part of the arm, and you can adjust this to determine when you want the low paper alarm to go off. As this moves across, it's quite clever. These metal strips on the base are actually magnetic field limiters. So what they do is they prevent the magnetic field from the magnets from getting across them. The only time the magnet can affect the switch is as it leaves this metal plate. So you'll hear it, in fact you probably can't hear it, but as this magnet starts to clear the plate, it operates the switch, and that gives it a very well defined position of operation rather than being a vague operation as it would be without these metal plates here. And it's the same on this side. There's a sector here that's used to indicate if the paper's too tight or if the paper has run out. And as I said, this shoe on this side, the idea of it is it holds this in position, and I think that's for paper loading purposes. Okay, so that's all in the right place. It seems to be working as it should. There's obviously no tension on this cable because the punch head's not there. All the springs are in place, and now there's just a circlip that goes on here to stop the arm popping up. So I'll put that back in. Push it down into its groove. Okay, now another part that I think is missing is I believe there should be a washer on here, a thin PTFE washer or something, which I've got to source as yet, because I don't think the platter should be rubbing directly on the circlip. I haven't got one at the moment, but as soon as I get hold of one, then I'll pop that on there. So you can see the purpose of this magnetic catch. It just holds everything out of the way so you can load the paper. So that's everything on the underside of the platter. I can now refit the platter. I need to just pull the brake shoe out of the way. Okay. So as you can see, as the tension on the arm increases, the brake shoe moves away and it frees this up to spin. And then as the paper is fed off the reel, this moves back and the brake comes on and stops the reel from turning. And we have a pulley that goes on this spindle. And then onto this corner, and this is the bracket that we've just coloured. That goes on like this, but before we fit that we need to put the end pulley onto it. So this comes in through the bottom. Again, hopefully all these are the correct length. I made some very high quality engineering drawings, Dave CAD style. If I was doing this as a commercial venture, then obviously I would use a CAD system, but on one-offs like this, especially because it's kind of potentially development, I don't know if these are going to work or not. So I tend to just do sketches. Okay, so that screws up nice and tight. We then have another one. So as I said, this recess at the end goes around this boss, and then the second post for the second pulley goes through this hole and fulfills two functions. It holds this down, and it also of course gives a position for the second pulley. I don't know what size the pulleys were supposed to be, but I've created a geometry here that makes sure that as the paper leaves the reel, it doesn't go back and encroach on the full reel. So imagine the reel's full, then the paper comes out quite a long way. So we'll just tighten that down. Hopefully also, as you can see, this is offset, so if you put a ruler on here, it's angled, so this pulley will be further this way than the other one. We can now fit the pulleys. Not quite tight enough. I'll screw this way in 5 yet. Okay, so they're all free. So in theory that's it. It should all now be functional. I'll try putting a paper tape reel on it. Actually, it's the first time I've tried this, so I don't know quite how well it's going to work, if at all. So that, I believe, goes around there. I think I've got that. Can we have that upside down? It's supposed to go the other way up. So I think it goes that way up. And I believe this goes round this pulley. It goes round here. And then this round here. And then I think that the idea is that this thing goes through into here. And of course this would normally then be unlocked. So the idea is that I'll pull this, and as you can see what's happening is as it's being unwound, this is very subtly controlling the brake shoe in this corner. So as it pulls it further this way, you'll see if I pull it manually that it frees up the paper tape reel. If I push it back, it locks it. And the idea is that depending on the tension you put on the spring that controls all this, it controls the tension of the tape, and it also controls the unwinding of the reel. Quite often you find on these tape reels that certain layers stick to each other, so sometimes it needs a bit of a extra tension, and that's what this mechanism is for here. It's kind of a shock take-up feeder, so it's kind of a buffer for the tape, so it doesn't cause the punch to miss-punch if it gets a sudden jolt on the tape. So it's quite a nice system, and you can see it is actually working. It's the first time I've tried it. It does seem to be working extremely well. I'll put that into the proper place. So as I pull the tape, it's not taking much effort at all. This is not touching on here. It looks to be touching, but it's not. There's about a ½ mil gap, which is what there should be. The tape is, I think it needs a bit more tension, but yeah, it's looking good. I think that's going to work. And then of course, if you want to lock it, you just put that back there. Okay, that's it for this video. In the next video we'll look at the punch head, and then once we get the punch head back in place, we can get the rest of this hooked up, and I think that will put a bit more tension on this because it will have some tension on that small cable, and hopefully from that point on we can start looking at the electronics.